Okay, this video is for students who need a beginning of the year review for AP Chemistry or Chemistry 1 students who are in the middle of learning about charges of ions. This is by far one of the most difficult concepts for Chemistry 1 students, at least in my observations, is figuring out the charge of an ion for the main group elements. So for the main group elements, here is what we're talking about. Groups 1, 2, 13, 14, 15, 16, 17, 18. This video is not concerned with transition metals. That will be addressed in a different video. That's going to require more work that doesn't fit the pattern we're looking at today. So I was thinking about how to make it as simple as possible, and here's what I came up with. Number one, find the element you need on the periodic table. Now I have a blank periodic table here. Hopefully you have one in front of you that you can use as a reference. I will write on this one as needed. So the first thing is find the element on the periodic table, and we want to know what is its atomic number. Atomic number meaning number of protons. So it's going to be a whole number. It's going to be a number 1 through 118. What is the atomic number? Second step, I want you to find the closest noble gas, which is an element in group 18. So your closest noble gas needs to be somewhere in this area over here. And we're going to relate these two things to figure out the charge of the element or the ion. So what is the atomic number of your closest noble gas? I'm going to go through an example for every main group. So you're going to get 8 examples here. So we're just going to start left and go right. So group 1, we're talking about the alkali metals. And I'm going to look at sodium. Sodium is here, and it has an atomic number of 11. So my element is sodium, and it has 11 protons. That's the atomic number. Now, what is the closest noble gas to sodium? Well, they are all the way across the table, but in terms of atomic number, we have 2 options. We have neon, which is 10 protons, or we have argon, which is 18 protons. So in terms of atomic number, which one is closer? Well, 11 is closer to 10 than it is to 18. So we are going to use neon. Neon with an atomic number of 10 protons. Determining the charge of an ion is really about figuring out the relationship between protons and electrons. So the charge of an ion is the number of protons in an element minus the number of electrons in an element. And that's the definition of it. But I've been thinking about it, and this is what I'm going to show you today. The charge of an ion equals the number of protons in the element minus the number of protons in the noble gas, which these two things, number of electrons in the ion and the number of protons in your closest noble gas, are actually the same number. And they are related, but to keep things simple, I'm going to use this over here to illustrate what's going on. So, a sodium atom has 11 protons. And we're going to say minus the number of protons in a noble gas, which is 10. And that gives us a number of positive 1. Positive 1 is the charge of every element, every ion in group 1. So this would work for all of the group 1 elements. What's really happening here is that sodium has 11 electrons, and as it becomes an ion, it loses one, and it only has 10. Lose one electron. And so to go back here to more the definition, the charge is it has 11 protons minus the ion's going to have 10 electrons equals, and again, we get positive 1. So that's what this is going to look like. Everything in group 1, let's write this down. Charge of all group 1 elements, positive 1. Okay, so now I'm just going to go all the way across with the main groups. Number 2, group 2, the alkaline earth metals. So we're going to look at calcium, which is here, and has an atomic number of, let me try that again. Has an atomic number of 20. So my element is calcium, and it has 20 protons. The closest noble gas would be argon with 18. And so if we're going to use the protons of the element versus the protons of the noble gas, here's what it's going to look like. Calcium has 20 minus argon has 18, and we end up with positive 2. And this is the charge of all group 2 elements. So what's happening here is we have calcium with 20 electrons. This is when it's neutral. When it becomes an ion, it lost 2 electrons, and now it has 18. So we lost 2 electrons, and that's how we end up with our charge of positive 2. So putting the numbers here, number of protons is 20. That number is never going to change. Minus the number of electrons of the ion, which is 18, and that's going to be, again, positive 2. Let me erase that and try it again. That didn't work. Okay. Wow. All right. So, positive 2, charge of all group 2 elements. With group 1 and 2, it's actually pretty easy. As long as you remember they're positive, the number is the same as the group number. So we are skipping the transition metals in the middle. They are a little more complicated than the method that I'm showing today. We are going to look at group 13. Specifically, I'm going to talk about aluminum, which is found here, and which has 13 protons. Atomic number 13. The closest noble gas, now this again, you'll have to pay some close attention. You have 2 choices. There's neon with 10, and there is argon with 18. Now, which of these 2 numbers is closer to 13? 13 and 10, they're 3 away. 13 and 18, they're 5 away. So we're going to go with neon for this one. And neon has 10 protons. So looking just at the protons of these 2 elements, we have 13 for aluminum, minus 10 for the neon, and that would tell us positive 3. What's happening with the aluminum is that we have 13 electrons and it's losing 3. It's only going to have 10 electrons. Loses 3 electrons. And that's what gives us a positive 3 charge, because we lost 3 and these are negatively charged. So in terms of electrons, we have 13 protons in the aluminum, and the ion has 10 electrons. And so 13 minus 10, you have positive 3. And positive 3 is the charge of at least the upper group 13 elements. With group 13, they're mostly metals, most of them. And once you get towards the bottom, it might be a little bit more complicated. So I don't want to say that all group 13 elements, but at least the ones at the top. And I'll just leave it at this. Group 13 has a positive 3 charge, because we really don't work with the group 13 elements down here in my classes anyway. Next up is group 14. Carbon is the first element in this group, has an atomic number of 6. We're not going to mess with this in group 14. Okay. Carbon and in general group 14 does not usually form ions. So whenever we're talking about ions and charges, we're not usually going to talk about carbon. Usually carbon is making covalent bonds, and so that's a completely different issue than today. All right, so we're looking at group 15 now, and I'm going to be looking at phosphorus, which has 15 protons. So here's phosphorus, 15 protons, and it is closest to argon. Argon has 18 protons. So looking here for the charge, 15 protons for phosphorus, 18 for argon. 15 minus 18 is negative 3. It has a negative 3 charge. Here's what's going on in terms of the electrons. A neutral phosphorus has 15. The ion has 18 electrons. So what happens is we have gained 3 electrons, which is where we get this negative 3 charge, because each electron has a negative 1 charge. So in terms of over here with the definitional part, protons 15 minus electrons for the ion, which is 18, equals negative 3. Group 15 elements are going to have a negative 3 charge. Now we're on to group 16, and I'm going to look at oxygen, which has an atomic number of 8. Every year at the end of the second semester, I still have students who can't tell me the charge of oxygen. And so we're going to try to get this as fast as we can. Oxygen pretty much always has the same charge. It is very, very reliable. Element, oxygen, 8 protons. The closest noble gas is 2 over, neon with 10 protons. Try it again. Neon with 10 protons. So looking at the proton method, comparing the two elements, we have oxygen with 8 minus neon with 10, and that's going to tell us the charge is -2. So here's what's happening. We have an oxygen that is neutral with 8 electrons, and its ion has 10 electrons. It has gained 2 electrons. 2 electrons gained means -2 charge. In terms of the electrons and protons over here, oxygen has its 8 protons. Its ion has 10 electrons. 8 minus 10 is -2. And group 16 elements will all have a -2 charge. Next, we're looking at group 17. These elements are known as the halogens. Those terms can be interchangeable. Halogens are group 17. And the element I picked is here, bromine. Bromine has an atomic number of 35. So the closest noble gas is immediately next to it, and that would be krypton with 36. So our element is bromine with 35. Closest noble gas is krypton with 36. So looking at the proton method, we have 35 minus 36, and that tells us -1. All group 17 ions will have a -1 charge. Here's what's happening to bromine. It had 35 electrons. It gained 1, and now it has 36. Gained 1 electron, which is how it gets the -1 charge. In terms of the protons and electrons of bromine, it has 35 protons. Its ion has 36 electrons, and that tells us -1 for the charge. For the last main group, we have group 18. These are the noble gases, and these are the ones we've been working with. So I'm going to take a look at argon. Remember, it has 18 protons. So our element, argon, 18 protons. Closest noble gas is argon with 18 protons. So when you're looking for the charge of a noble gas, this is really unnecessary if you just remember that a noble gas will always have a charge of 0. It does not make ions, and they don't like to form chemical bonds. But for comparison purposes, we had 18 protons. 18 is the number of the closest noble gas. Charge is 0. To describe what happened, it did not gain or lose any electrons. And so in terms of the protons and electrons of argon, it has 18 protons minus, it didn't gain or lose, so it still has 18. Try that again. Still has 18. 18 minus 18 is 0, which means neutral. all group 18 elements will be neutral. Hopefully this is helpful. If we need, I can make more videos. Thanks for watching.